As children with visual impairment are now being enrolled in inclusive education, more teachers are finding themselves in the position of having to address issues of preparation and presentation of adapted tactile materials to these children. This unit aims to help these teachers by providing a basic introduction to tactile graphics, that is diagrams, charts, maps, graphs and globes, which can be felt as well as seen. Diagrams, illustrations, models and maps can, despite being abstractions of reality, materialize space and organize information received by touch. Maps can be used to locate and orient oneself and to move around. For children with visual impairment, these resources can be used to help them move around in their everyday lives, to school or around the neighborhood. In this way, the map is fundamental to the perception and construction of space by the user, mainly because she or he cannot receive spatial information through sight. Tactile graphics are a means of conveying non-textual information to children with visual impairment and may include tactile representations of pictures, maps, graphs, diagrams and other images. A person with visual impairment can feel these raised lines and surface in order to obtain the same information that people who are sighted get through looking at pictures or other visual images. The ability to learn through pictures and diagrams is crucial for the acquisition of knowledge. It is desirable that parents and professionals work together to enable children with visual impairment to learn through tactile graphics. In the early learning stages, tactile images can be enhanced by the accompaniment of audio input, making the image more meaningful and interesting. Today, more so than in the past, children with visual impairment need to have well-developed tactile graphic reading skills. They can use graphics as the medium for acquiring concepts, spatial skills and accessing the academic curriculum. Children with visual impairment do not have visual access to the world. The world around them needs to be recreated into a form which is accessible. This is often done through verbal descriptions, exploration of immediate environment and presentation of tactile models and graphics. It is through tactile models and graphics that a child begins to be able to relate one object or concept with another. A relationship can be observed with images that appear on a page. The concepts that are represented using comparative language can be easily demonstrated with a number of tactile drawings. The relationship between objects becomes evident when presented in graphical form. Take for example, a scene of a suburban home. The positioning and sizing of the entities can be easily compared. The house is bigger than the dog. The windows may not touch the ground. The roof is on the top of the house. The top of the tree is wider than the trunk. A great deal of information can be absorbed incidentally through exploration of a diagram. After being exposed to a variety of tactile images, children may not need to ask such questions as, why don't aeroplanes crash into power lines? Through exploration of maps, both local area maps and larger scale atlases, an understanding of the spatial relationship between places should develop. Children's books have traditionally relied heavily on the use of graphics to tell a story. Braille books in the past were notably short of tactile images. In many cases, this was not a problem. That is, when the print graphic was only present for aesthetic reasons and not for conveying any message. It is when the print drawing was of assistance to the reader in enhancing the story that any omission of similar tactile graphics was denying the Braille reader the same information as the print reader. Humanities and science subjects relied heavily on diagrams that were very straightforward and fairly easily transcribed into a tactile image. These days, with an improvement in graphical displays and a heavily reliance on photographs, more creative effort has to be put into portraying this vital information. Education is changing, the emphasis not as heavily on the reproduction of rote facts. Children more and more these days are expected to be able to interpret and extract information from graphical stimulus in various formats, either as tables, graphs, maps, charts, diagrams and pictures. With this change in focus, it is now more than ever essential that the tactile readers are proficient in reading tactile images. Like any form of learning, the younger the learning commences, the greater the chance the child has of mastering the skill. Many are probably already encouraging parents of preschoolers to expose their children to tactile models and images. As the sighted child learns foundational concepts from being read to aloud regularly from infancy, so too does the vision impaired child. There is a difference when reading to a child with vision impairment. They may not have access to any graphical material on the page, and due to this lack of additional input have trouble forming a complete understanding of the concept. We know when we meet vision impaired people that it is courteous to quickly introduce yourself to take the guesswork out of the meeting. We should be applying the same principle when introducing a tactile image in the early stage of learning. Tell a student what the image is. Explain to the child what they may find on the page. This can only lead to success and enjoyment of. Make the tactile graphic as clear as possible. Always keep in mind the point of view of the braille reader. It is up to the producer to present the information in a clear, concise manner for the student. Know the important facts to be kept in mind when creating the graphic. Determine if the original shapes and textures are necessary to convey the concept, or can simple geometric shapes or braille signs be used to illustrate the concept. Omit unnecessary parts of the diagram, for example, unreferenced or irrelevant sections of a map, so that the original shapes and textures can be presented on a large and clearer scale. Keep in mind the knowledge level, skill base and age level of the reader. Use age appropriate language. Determine if the text requires measurements to be made or an operation to be performed, or if the original shapes, textures and total form are necessary to convey the concept. If so, the lines and angles are reproduced retaining a proper scale. Remember to keep it simple. Unnecessary information clutter may prohibit the student from gaining relevant information, therefore making the graphic useless. Edit or proofread the graphic with your fingers, not your eyes, before showing it to a student. There are three main production methods: swell paper, thermoform and German film. This is a special paper coated with invisible capsules containing alcohol. A black image is drawn or photocopied onto the paper, which is then heated in a special developer machine. The black areas absorb heat faster than the surroundings white areas, boiling the alcohol and bursting the capsules. The black areas swell permanently and can be felt in relief against the flat white background. The principal advantage of the method is its speed, although one must guard against the temptations to photocopy and raise diagrams which are not really suited to the tactile medium. The other advantage is the high contrast between the black and white. Color can be added with felt pens or crayons. The principal disadvantage of the method is the lack of variation in height. This method involves heating a thin sheet of cream colored plastic and vacuum forming it over a raised shape using a special machine. When the sheet is removed, it retains the shape permanently in relief. Relief molding of small objects can be made, but more often the method is used to produce multiple copies of master graphics made with materials such as cardboard, string and wire. The principal advantage of thermoform is that it allows heights up to 2 cm, which helps make the graphic clearer. The principal disadvantages are that producing the masters is time consuming. The plastic is a uniform color and does not take felt pens effectively. This is semi-transparent plastic sheet which can be drawn on using an ordinary ballpoint pen. The pen leaves not just an ink trace but also a raised line. The main advantage of this method is that it can be used interactively to create a graphic which children can feel at different stages of production. They can also make their own graphics. The main disadvantages of the method are that there is little variation in line height and graphics quickly become shabby as the film is flimsy. It is advisable to adopt a very selective approach in choosing which graphics to translate into tactile form, as the production and the use of tactile graphics takes effort on the part of the teacher and the child. Try the following 3-step procedure. Eliminate non-essential graphics. Be critical of the purpose of any graphic. Substitute essential graphics where possible. Keep a scrap box of empty containers, bits of wire, plastic lids, so you can produce visually impaired children with a hands-on explanation of concepts conveyed graphically to sighted children. A child with visual impairment confused by a raised line diagram of a coiled spring understood straightway when handed a coiled piece of wire. Redesign the remaining graphics if necessary. Do not get too disheartened at this prospect. The simpler the better is a good rule of thumb. A few quick marks will often produce a much more effective raised graphic than the original. When considering the design of tactile graphics, it is important to remember that touch does not allow such fine discrimination of detail as vision. Tactile information is also often harder to make sense of. Example, it can be difficult to distinguish between a foreground object and its background. Focus on the essential point of the graphic. Less is more really is the case here. Do not copy and erase photographs. Substitute with text or a diagram. Avoid line drawings where possible. For example, in the classic food chain diagram showing drawings of the animals, use a word label instead. Use filled shapes rather than outlines. Example for maps, otherwise it can be hard to know whether you are feeling inside or outside. Avoid label lines, these can get confused with the diagrams itself. Put labels on the relevant part or use a key. Keep lines at least 2 mm apart. You can get some idea of the clarity of a tactile graphic by trying it out on someone who has not seen it. But remember that a child with visual impairment may be confused by different aspects from a fully sighted child. Decide if a tactile graphic needs to be made at all. Omit the graphics if it does not convey essential content. Consider using a description to replace all or part of a graphic. Remember that children need to build up tactile skills with simple fingers. Consider providing graphics in children's books even if they are not needed for content. Graphics should be tactually clear and contain only relevant information. Based on and understanding of what is being taught and what the student's task is. Visual information that is relevant to the meaning or purpose should be omitted. Graphics should be redrawn in 2 dimensions where possible, with the exception of some mathematical and scientific diagrams. Replace 3-dimensional figures with cross sections or front side top views whenever possible. Look for perspectives that allow you to redo a 3D print picture in 2D. In cases where a graphic has been replaced by a table or chart, use braille code for columned material. Avoid clutter and simplify. Clutter occurs when different symbols and lines are so close or so similar that they become hard to distinguish. Spacing is the key to avoiding clutter. Symbols and lines closer than quarter-inch may be hard to tell apart depending on the medium and tools being used. Shapes with side less than ½ inch long may not be recognizable. Distort the spacing or shape of the original picture if necessary to allow uncluttered spacing of the tactile elements, providing this would not violate the purpose of the picture. Simplify means to eliminate unnecessary elements of the original picture, focus on the relevant parts and omit details that are purely decorative and distracting. When the print picture includes people, animals, objects, replace them with simple lines, symbols and or labels. Split complicated graphics into separate drawings showing layers of information or into an overview and detailed view. Explain the separation in a transcriber's note. Carry over some labels and common points from one drawing to another for reference. In general, use textures sparingly and only to add information. When necessary, to avoid confusion or to give important information, differentiate between bodies of water and land on maps by using a different aerial symbol. Use a very low, closely spaced texture for water. A real texture indicating ocean should extend it for enough to be perceived as a continuing expanse, but need not fill the entire page. Limit the lines, points and symbols on a drawing to ones that can be easily identified one from another by touch. Use the most prominent symbols for the most important features in the graphic. Don't allow high or noisy textures to draw attention away from the key features. Fill the copy of the graphic the reader will receive to see if you can follow all lines. Be consistent in using symbols within graphics of the same type within the same transcription. For example, always use the same symbol for water on maps. Use different tactile symbols for different types of information. For example, in a map of India, the tactile line used to indicate state borders should be different from the tactile line used to indicate international borders. Lines, points and braille must be physically separated. Use lead lines only as a last resort. Use keys or notes as alternatives. Do not use arrows as lead lines. The linear symbol used for lead lines should be different from any other lines used in the graphic and should be tactually distinctive but less prominent. A lead line should begin as close as possible without causing interference to either the first or the last letter in the label and should end as close as possible to the feature being labeled. Break the lines of the graphic to allow lead lines through. Explain and define all graphic symbols either on the same page, facing page or special symbols page. Identify all important features of the graphic, even things not labeled in the print version. Place titles at the top of the page. Do not make unlabeled graphics. Place labels in a manner that leaves the reader no doubts as to what is being identified. Single letters on the graphic should be preceded by either the letter sign or the capital sign. Words in labels need not be capitalized if their meaning will not be confused. Use grade 2 braille contractions in labels. A 2-cell braille symbol is preferable to a 1-cell symbol for labels. Try not to break the integrity of a shape with a braille. Transcription where north is at the top of the page on all maps indicates this in a prefers and do not indicate north on each map. On single maps or when north is not the top of the page, indicate direction by using a simple arrow labeled N. Position scale and other indicators as consistently as possible, preferably at the top of tactile graphics. When it is necessary to change the scale, this fact may need to be indicated in a transcriber's note. Place all titles, keys and legends before the graphic. Author's key and legends precede the transcriber's keys and legends. If there is not room on the page with the graphic, place on preceding page. A good tactile graphic is an excellent start, but a child will still need to be supported in its use. The following 7-step procedure should help. Check that the child is scattered square to the table to ensure consistent spatial orientation. Anchor the graphic to the table to prevent misunderstanding due to orientation changes. Ask the child to sweep the graphic with both hands to get an overall idea of the graphic size and complexity. Briefly explain the purpose of the graphic. Draw attention to any overall organization. Direct attention to specific parts, explaining each in turn and how it relates to other parts. Allow the child to feel for themselves. They will find this more informative than having their fingers guided all the time. Tactile graphics are not automatically meaningful to children with visual impairment. Students must first have an understanding of that which is being represented. For example, a raised map of Africa will have little meaning for a child who has never heard of Africa and who does not grasp the fact that the child is made up of different continents. In order for a tactile graphics to have meaning, a student must have a good understanding of symbolic representation, spatial orientation and basic tactual perceptual skills. Tactile maps, diagrams and globe are important for mapping and the teaching of social sciences, not just for the visually disabled but also for normal students. Tactile illustrations can be used in classrooms that have students with and without visual disabilities. This is a work of real inclusion for people in our society with special necessities.